Good morning. Today's assignment is going to be a little bit different. It's not going to be a worksheet. What I want you guys to do is kind of go back to your notes from last week and look again at these graphs, our polar equations graphs. So we have 6 of them: circle, rose, lemniscate, limison, cardioid, and spiral. So we've got these 6 to think about. And what I'd like you to do is take a walk around your house or your yard, or a hike maybe, and keep these 6 graphs in your mind and see if you can't find one of these, something similar out in nature or in your house. It can be man-made, or it can be a plant, or whatever you want. So I would prefer if it wasn't just a circle, but if that's all you can come up with, that's totally fine too. Okay, I'm cool with that. So what your first assignment is to go ahead and brainstorm and find your object, and then take a photo of it. So that's going to be part of what you're going to turn into me, is one picture. And then what I'd like you to do is then play with your calculator, if you have a calculator. So what I'm going to kind of show you is what I did. So on my phone, this weekend I took a picture. So let me get into my phone here. Okay, so here's my photos, and I took a picture of a flower. So here you go. So this is called a trillium, and you guys can see it. I'm a terrible photographer, but you can see it's a little bit blurry, but you can kind of see the petals here. And so it has 3 petals. So I took something fairly easy, right? And I'm gonna say, okay, that's my rose, right? And it has 3 petals. So I'm gonna kind of play with it on my calculator. So I'm gonna use the calculator. I'm gonna use the polar function. So I wanted to show you how to do that. So if you have the TI-84, it's gonna be different in the Inspire, and I honestly don't know how to do it. So I can show you on the TI-84, and hopefully you guys can play with the mode and whatnot on the Inspire, and hopefully get it to work. So the thing that you want to focus on is this button mode. So press that button, and you can see we want to be in degrees, because we want to work in degrees here. So make sure you're in degrees. And then go one more down, and you can see, okay, typically we're in functions. We don't want to do parametric. We want to go all the way over here to polar and select that, okay? And then when you go to your y equals, you'll notice something funny. It ends up being r. So just like a polar equation, you're going to have r equals. Now, if I go back to my trillium, or my flower, the length of the petal is that A. It's the one number in front of sign. And my trillium, it was about, I don't know, it was about this big. So it was about 3 inches total across. So I'm thinking it's probably about, one petal is probably 1.5 inches. So we could do 1.5 and sign. And then it has 3 petals, so I'm going to put a 3 in here. Now if it had an even number of petals, remember that's 2 times the number. So if it had 4 petals, you'll want that number to be a 2. If it had 8 petals, you'd want that number to be a 4. Okay, and then we're just going to put in theta and close that parenthesis. And then you'll have to do you might have to do some finagling in your window to get it to work. You'd probably want your range to be 0 to 360. The step, it'll just, if you do like 0.5, it'll just take longer to graph. and be slightly more accurate. And then you'll have to work with the scale to make sure it fits on your inside the window. So we'll go ahead and do a graph. And it's kind of fun to watch it graph there. So you can see that. So that's kind of cool. And if you want it to look bigger, we can change the window. Oh, it's still thinking. You can see up here, if you still see something going, it's still thinking. So then you'll go to window. And if you want it bigger, maybe we'll do -2 to 2, -2 to 2. And then it'll fill up more of the screen. It'll be nice and big. And you can see how that polar graph starts out and dips down. So there's my trillium, and I'm going to go ahead now and graph that on my paper. And that's what I obviously I don't want your calculator to be turned in. So we're going to go ahead and graph that. And that's pretty similar to an actual trillium. It's not oriented exactly the same in my photo, but we're gonna call it good there. And this is 0 and 90 and 180 and 270. And I am actually going to write, so I want you to write your equation out. So it's R is equal to 1.5 sine of 3 theta. And let's put in a table, and you can use the table function on your calculator if you're not super comfortable. Theta there, and R, and we can also use our calculator here. So if you want to use your table function, we can always put in 0, and we know that's 0. And 3 theta, right, is if I put in 30 degrees, or yeah, 30 degrees, I go 3 times 30 is 90. I know what that's going to be, right? So 3 times 30 is 90 sine of 1. So then I get my 1.5. And so then you can see why the petal is along that 30-degree line. That furthest point out is going to be 1.5. So I'm going to just kind of show that. I'm going to estimate 30 degrees here. This is 30 degrees. And I'm going to estimate 150 here. So I know that's going to end up being, there we go. There we go. 30 degrees. So that's another 30 degrees over there, 150. So you can see 150 times 3, right, is going to be, what is that, 450? So 150 times 3 is 450. So it's going to go around a bunch of times, right? So 150. And sine of 450 is 1. So we get 1.5 again. So you can see how that kind of goes. And it might be kind of nice to use that table function and plug in some angles as we go. So what's kind of interesting too here is if we plug in 90, 3 times 90 is 3 times 90 is 270. So we get sine of 270 is a negative. So at 90, we're going to go down here. And you guys saw that in the calculator so it's a negative 1.5. So let's use the pink pen and go ahead and we're going to go, let's make our scale big. 1. So that's about 1, 2, and 1, and 2, and 1, 2, 1, and 2. So here we go. We're going to go up. So this is 1 1/2, 1 1/2, 1 1/2. So we go up and out and down and around. And you know that this didn't look exactly like my flower, but it was close, right? It has the 3 petals. And that's it. That's really all you have to turn in is your equation and a drawing of it. So hopefully that'll be a fun assignment for you, get you out of the house, or at least out of your bedroom maybe, and give you something to do. And if you feel like coloring it or whatever, you can help yourself. Okay, thanks guys, hope you have fun with it.